Welcome to qnawire.
So for this problem, you would use the multinomial formula, and the multinomial formula reads P of x equals n factorial over x1 factorial times x2 factorial times x3 factorial all the way to xk factorial. And then that fraction is multiplied by the probability of success for the first event raised to the x1 power times the probability of the second event raised to the power x2, and you would keep that going as well till you get to the probability of the k event raised to xk power. So in part A, we have all of the information that we need. So we are going to substitute everything in. In this case, the n was 6, so we'd have 6 factorial on the top. x1 was 3, so we're going to have 3 factorial. x2 was 2, so we're going to have a 2 factorial. x3 was 1, so we're going to have a 1 factorial. Then we're going to multiply it by p1, which was 0.5, raised to the x1 value, again, was 3. Then we multiply that by p2, which was 0.3, and raise that to the x2 power, which was 2. And we multiply that by p3, which was 0.2, and we raise it to the x3 power, which was 1. And if you type that into your calculator, you should get a probability of 0.135. For part B, same formula. Our n value was 5, so we'll have 5 factorial in the numerator. Our x1 value was 1, so we'd have 1 factorial. Our x2 is 2, so we're going to multiply that by 2 factorial. Our x3 is 2, so we're going to have a 2 factorial. And now we're going to multiply it by the probabilities. P1 was 0.3, and we raise it to the x1 power. P2 was 0.6, and we raise it to the x2 power. And P3 was 0.1, and we raise it to the x3 power. And if you pick up your calculator and perform this calculation, we get a value of 0.0324. And the final part, letter C, same formula, different numbers. So in part C, our n value was 4, so we'd have 4 factorial. Our x1 was 1. Our x2 was also 1. And our x3 was 2. And now we multiply it by p1 raised to the x1 power. And p1 was 0.8 raised to the x1 power. p2 was 0.1 raised to the x2 power. And p3 was also 0.1 raised to the x3 power. We would put these into our calculator, and we should get an answer of 0.096.